All right, class, this is Mr. Hart. I'm just making this podcast to go over the topics in week one for motion. So if you haven't printed them off already, you should have a copy of the class notes or the class outline for the different vocabulary words and equations you need for this unit. Okay, so make sure you print that off and follow along with it. Okay. So the first thing we talked about was distance versus displacement. Okay, we use these two terms a lot in physics. Okay, and to show the difference, let's look at this motorcyclist. Okay, as he travels along this path to get to the factory for work, right? His distance is this total length he traveled along the path, whereas this displacement is this distance just between the house and the factory, or as the crow flies, you could say. Okay, so that's how we distinguish. So distance is the total length of the path traveled, and displacement is just the length between the start and finish points. Okay, so distance, displacement. Displacement is always a straight line. Okay, so that leads us to our equation. The displacement equals the change in position, or the final position minus the initial position. Okay, this little delta sign, this triangle looking thing called delta in Greek, means change. So change in position equals final position minus initial position. Okay. So, for example, this guy in the car, he moves over to 10 meters. Okay. And let's say he turns around, comes back to 5 meters. Okay. His distance would be 15 because he travels to 10, comes back to 5. That's a total of 15 meters. But his displacement would only be 5 meters. Okay. Because his start point was 0, his end point's 5. Okay. Displacement is 5 meters. Okay. So hopefully that illustrates the difference. Then we talked about speed and velocity. So same thing, motorcyclist goes around. Let's say it takes him 10 minutes to get from here to there. So if it takes him 10 minutes to do so, then his speed is going to be his total path traveled over his time, whereas his velocity is just going to be this displacement over time. Okay, so that's again the difference. So speed is the distance over time, velocity is the displacement over time. Okay, so they're related just like displacement and distance, velocity and speed behave the same way. Okay, so that leads us to the velocity equation. So the average velocity is the change in position over the change in time, which if we wrote it out in full form, it would be final position minus initial position over final time minus initial time. Okay, but usually we can just stay and look at this equation right here. Usually this makes enough sense for us. Okay, so again, same thing with the car. He moves over here, turns around, comes back, and let's say it takes him 5 seconds to do that. Okay, well, his distance was 15 meters again, so his speed would be 3 meters per second, 15 over 5. But his displacement was only 5 meters, so his velocity would be 5 over 5, or 1 meter per second. Okay, and when we think about this, it's also good to keep in mind that we can solve for distance. So we have our velocity equals the change in position over change in time. And I apologize for the sloppy handwriting on the computer. But velocity equals change in position over change in time. So if we need to know the position instead of the velocity, if we know the velocity and the time, we can times this over here, okay? And we get velocity times change in time equals position, okay? So these equations can be manipulated in any way we need to in order to make the most sense. So if we have the velocity and the time, we can find the position, okay? All right, so then you are assigned homework 1. So that should be on the website, and you can download that and do that if you haven't. Okay, and here's just a review question for you if you want to do it. Okay, so if you want to try this, pause it and do that. Okay, then we did the height versus speed lab. Okay, so this is a lab we did after school. The instructions are online. But the question you were trying to answer was, how does the height of a ramp affect the speed of an object? Okay, so do that lab, and you'll see an interesting behavior with the height versus the speed. Okay, so the next thing we talked about was position time graphs. So a position time graph is just a graph of the position of an object at any given time. Okay, very intuitive name. So, for example, let's say an object is here. So it starts at 0 meters. This graph is showing that the object is moving forward until it reaches 60 meters. Okay, so at 10 seconds, this object is moving forward at 60 meters. So if you imagine a person walking, they walk forward for 10 seconds, go to 60 meters. Then this shows that they stop, right? They stay at 60 meters, so they're not moving for 5 seconds. Then they go backwards, so they're at negative 40 meters. And then they go back forward again. So if a person's walking, they'd be walking forward, they'd stop, move backwards for a while, and then move back forward. Okay, so that's what the position time graph is telling us. It's just what the position of that object or person is at any given time. So try this one on your own, on your paper. Describe the motion of an object shown by this graph. Okay, so look at this position time graph. Describe to me what the object would be doing. All right, so then we talked about velocity time graphs. This is a little bit hard to see, but this says velocity, this says time. So it's the same thing as a position time graph, but it instead is telling us how fast the object is moving at any given time. So if you look here, this object is staying still, then it's speeding up until it reaches 8 meters per second. Okay, then when it is at this point, it stays moving at 8 meters per second. This doesn't mean it's stopped, right? Flat line doesn't mean it's stopped in a velocity graph. It just means that it's constantly moving at 8 meters per second. Then it slows down until it goes to 4 meters per second. So you can imagine if this was a person, it's like them stopping, okay? Then they speed up and start running at 80 meters per second for a while. Then they slow down and start walking at 4 meters per second. So you can think of this velocity time graph like a race, right? They're in the starting blocks. They shoot off until they can get to 8 meters per second. They're running, they're running, they're running. They finish, they slow down, and they walk it off. Okay, that's what this velocity time graph is showing. So here's another example. If this is a velocity time graph, this person is running fast, and then they slow down till they reach a stop. Okay, so those two examples. So try this one on your own if you can, of what this object or person would be doing. Okay, this is again velocity, this is time. Okay. Then the last thing we talked about was motion detection. So these little devices here are motion detectors. So this speaker, what it does, let's say there's an object over here and it wants to know how far away it is. This speaker will emit sound waves towards the object. Okay, when that object is hit by those sound waves, the sound waves go back towards the motion detector. Okay, and when this motion detector speaker or microphone hears these waves come back, it just uses a simple equation, right? The change in position equals velocity times the change in time. So we've used this equation before. So we know the change in time, right? That's what it's measuring. We know the velocity because we know the speed of sound. So from those measurements, we can find the distance. Okay, so it's plopping those waves back and forth, measuring the time so it can figure out how far away the object is. Okay, really simple device conceptually to understand how it's detecting motion. Okay. All right, then the last thing we did is we were assigned homework. Okay, homework 2, which is position time graphs. So again, those are on the website, so if you want to do that, look that up and turn that in. Okay, so hopefully this review made some sense. Let me know if you have any questions or post them on the discussion board. And thank you for watching.